Hey folks, I wanted to go over these practice problems that I posted. Some of you had asked for that, so let's look at these real quickly. These would be some reminders and just to help you think through how you need to think through some of these things. So two linear measurements gives us, if we're multiplying those, get area, we get a square measurement. So feet times feet equals square feet. Alright, inches times inches, square inches, meters times meters, square meters. So just make sure you're using the right terminology. If you have three linear measurements, like height times width times, let's say, length of a house, I've got this measurement, height, I've got maybe width, and I've got length, then I get a volume. So height times length times width equals a cubic something. Alright, so we'll just say those are all in feet. Alright, gives us a volume measurement. If I ask you to calculate the air volume of a surface, so right there should be your first clue. Volume and surfaces. This is a square measurement, this is a cubic measurement. So your antenna should be going up. It's 30 feet long by 8 feet high. How would you respond? Well, you could respond by saying we don't have enough information to calculate volume because we need three linear measurements. Okay. What is the footprint, the floor area of a rectangular house whose long walls are 50 feet and its short walls are 27? So just draw it out. There's a rectangle. Long walls are 50. Short walls are 27. 50 times 27 is what? Let's do that real fast. 50 times 27 should be 1350. 1350 what? Square feet. Area. Okay. Total conditioned volume of this house, assuming that the thermal boundary is represented by the heavy line. So what goes on at the thermal boundary? You guys should be able to tell me what two things come into alignment at the thermal boundary. So we've got simple measurements. It's 20 feet wide, 30 feet long, 8 feet tall. 20 feet wide by 30 feet long by 8 feet high equals 20 times 30 times 8. It's like 4,800. 4,800 what? Cubic feet. Alright, that's pretty straightforward. What's the area in square feet of a window that has these inch dimensions? Well, let's do it in inches. 36 inches times 60 inches equals 36 times 60 is 2,160 square inches. And we got to convert that to square feet, so we know that 144 square inches in 1 foot squared. Cancel that, top, bottom, units cancel out. That divided by that, 15 square feet. We can check our answer because 36 inches, hopefully you know that that's 3 feet. 60 inches, you know that that's 5 feet. Same thing. Alright. Sometimes these are really easy to convert to feet right off the bat. Sometimes they're not. If I gave you something like 27.5 inches, it'd be easier just to do it by inches than convert it all to feet. Now I'm asking you to include this attic space in the conditioned volume. Alright, so it's the same house as up here. 20 by 30 by 8, 20 by 30 by 8. But now we're including this. So we know this volume was 4,800 cubic feet. Now we have to calculate this volume. Well, this is simple. It's a triangular prism. So if you just think of let's do the surface area of the triangle and then multiply it times the length. Alright, so we've got base, 1/2 base times height gives us an area, and then if we multiply that by another dimension, we get a volume. So the base is 20, 1/2 times 20 times the height is 10 equals 100 square feet. Get that on there. That's the area of this triangle. Of the little triangle. Now, it's 30 feet long, so let's take 100 square feet times 30 feet length. We're going to get 3,000 cubic feet. Okay. We add that to that. We get 7,800 cubic feet. This would be pretty straightforward. Just the area of a triangle, 1/2 base times height. Alright, don't see this a lot, but just in this week I've seen 2 structures that had cylindrical features in them. So I'm asking you, what's the total surface area of a cylinder that has a flat top and a flat bottom? I said it's got a pointed roof, but the thermal boundary stops at the ceiling. So a cylinder kind of looks like that. And you can't really see that in there. It's the bottom. So what information do we have? We know it's 17 feet tall, and we know it's 100 square feet there and 100 square feet here. So what information do we have, and what do we need to find? Well, we need to find the area of the cylinder sides itself. So let's think of some of our formulas that we use for cylinders and circles. If I know this dimension, then I can multiply that times this and get an area. And to show that to you, just imagine, I'm going to back this camera away for a second. If this is just a rectangle, well, when I roll this rectangle up, it becomes a cylinder. What's the length of this distance? The length of that distance is just that straight line. Nothing changes when I roll it up. It goes 8.5 inches. I roll it up into a cylinder. It's 8.5 inches around that circumference. Alright. So let's look at area. We've got the area of a circle equals pi times the radius squared. That's just a formula that you knew at some point in your life. You might not remember it now. So what do we know? Let's go area over pi equals r squared, because we're trying to get radius, because from radius we can get circumference. Well, I want r, so let's take the square root of both sides. And if I do the square root of 100, and we'll do pi at 3.14, equals a radius of 5.6 feet. Alright, so from radius, that's this point from the middle of the circle out to the edge, from radius I can calculate that. I know that circumference equals 2 times pi times r. That's another formula you used to know at some point. You might not remember it now. Equals 2 times 3.14 times 5.6 equals 2 times 3.14 times 5.6 equals 35. We'll just call it 35. Alright, so now I'm saying that this distance is 35 feet, this distance is 17. 35 times 17 equals 595. 595 what? Square feet. 595 square feet plus 100 square feet plus 100 square feet. $795 square feet. Okay, so that is really not a difficult problem. It requires you to stop, requires you to draw it out, requires you to remember some things about circles, and to visualize a cylinder as just being a flat thing that was rolled up. If I ask you to calculate the area of this, you would say, well, it's 8.5 inches by 11 inches. Alright, well, when I roll it up, it's the same area. It's just now you have to go, okay, what's that size? I know it's 8.5 because Haddock's just rolled up a piece of paper. But what if I didn't know the size of that? How could I calculate it? Alright, so there you go on those. If you have any questions on that, give me a shout.